So that's how a magnetic starter works. I talked to several people to understand it. Talked to a couple electricians so they could walk me through the whole wiring process, the wiring diagrams, so that I knew what I was doing before I got started. And so now's the time to test it. We're going to close everything up and see if this thing works properly. If everything works properly, you can see we don't have any PSI built up. If everything's working properly, when I hit that cutoff switch, it will energize the magnetic starter. It should automatically turn on this compressor, and whenever this compressor hits above 160, it should automatically cut off. If everything's wired up properly, that's how this will work. So let me get my my safety gear on and we will get started. All right, I got my gloves and my glasses on. We're gonna close this box here. And we'll go ahead and turn it on. So there you go. It cut off just a little bit above 160 psi. The pressure switch broke the circuit right there. If you look behind, we can see those contacts pulled away, breaking the circuit on the pressure switch. And because we broke the circuit on the pressure switch, that breaks the circuit on this solenoid. This solenoid shot back forward, breaking the contact from here to here, and that shuts the motor off. So we know we got it to turn off properly. The next test is to relieve the pressure. And once we relieve the pressure, once we drop about 30 psi or so, that pressure switch should close, which closes the loop, which closes the circuit, causing that magnetic switch to kick back on when this thing hits about 120 psi. So I will open up the relief valve, the drain valve. We will watch and see when this hits 120. If it kicks back on, then we have done everything right. There it is, kick back on. Go ahead and shut the relief valve. So that was the solenoid kicking off. You could see how it bounced back right there through that little notch there, breaking the circuit. So that was a successful test, even though it looks messy. And this is not a safe setup at all. We were able to test everything out and it works properly. So now I can disassemble everything, take it all apart, and start the cleanup and restoration process, starting with building the belt guard there. I can get all the proper wiring connections, and then start with the modifications that I'll be making to this. So my ultimate goal with this compressor is to make a complete dry air system. So what I will be doing is building a skid for it. So the whole thing will rest on a skid that's probably somewhere around 12 or 10 feet long. On the back side of the skid, I will be putting condensers in place. And this port here will be tied directly into the condensers that will go on this side, and that will be the first stage to cool down this hot air. If you touch this right here, it's very hot. So with hot air comes moisture, and you want to pull all the moisture out of that air. So I'll run it through a condensing unit. After that, I will be building a water separator. Now I'm not real sure where I'm going to be placing it. It'll be a pretty large water separator. I want to try and balance this thing out as best as possible. This motor weighs a lot, and it puts most of the weight on this end of the compressor. So I'm thinking about putting the water separators on this end of the compressor so that I can try and balance it out. And I'm not sure yet if I'm going to put one or two. I'm going to have to think about it. But I'll put either one or two water separators over here. And then in front of that, I'm going to build a control panel. So that control panel will be facing this way. So when we look at it from this angle, we will be directly on the control panel. And on that control panel, I'm going to have a PSI gauge that shows the exact PSI that's in the tank. I'll also have 4 ports, outlet ports, so that I can plug into any 4 of those ports as necessary. I'll also have a start switch, a cutoff start on switch, and I'll have an emergency cutoff switch. And then I will also want to set up individual pressure regulators for all 4 ports, so that I could be using one port for paint setup, I can use one port for the can crusher, I can use another port for impact tools, and then the last port, for whatever. So just an example, I can set all 4 of those outlets up to their own individual pressure while maintaining 170 psi in the tank at all times. So that's the ultimate goal there. And then I don't know when I'll be able to get to it. I'll have to do some research, but I would like eventually to put a refrigerated dryer on the back end of this. So the condensing units are the first stage of drying the air. The water separator pulls the water out, and then after that you can run it through a refrigerant air cooler, which then takes that hot air, it drops the temperature down, which creates more moisture. Then you can separate that moisture out again and get the driest air possible. So why do you want the driest air possible? There's a couple reasons. If you're using impact tools or general air, you don't really need the driest air. But if you're going to be doing painting or automotive type paint or high-end industrial paint, you want that air to be as dry as possible, because you don't want it to contaminate your lines, your equipment, or your paint. And the other reason, which is more of the reason why I'm looking into it, is with plasma cutting. When you're doing plasma cutting, you want that air as dry as possible, because if you've got any condensation in those lines, it will destroy your consumables in your plasma cutter, especially when you get into CNC type plasma cutting and you want precision cutting. You want those consumables to last a long time, and you want those consumables to be very precise when they do the cutting. And having the driest air possible is what allows you to do that. So it'll be a long process, it'll be a long build, but it'll be fun. And I'm gonna try and get as much as I can captured on video so that you can see the whole process. And then this thing will be a whole dry air unit all in itself. So the compressor is the foundation of that. I've got the compressor, I've got all the wiring figured out. Now I just need to put it all together and make it work. So I'd love to have any of your advice, any help with this build. There's not a whole lot of material out there. There's a lot of dry air systems just that are kind of do it yourself, but nothing that's really that gives you detail on an industrial type machine. So any comments, please leave them down below. I'm sure there's plenty of people that are going to comment on my wiring here, so that's fine too. You can go ahead and leave your 2 cents down there. Like I said, I know this isn't the safest setup, but I got it to work. Now that I know it works, now I can put it all together and make it as safe as possible. Well, all right, that's the newest project here in the shop. Thanks for joining F8N. Go build something.